Good morning, folks. This is Mr. Walker here coming to us with our new lesson. We are talking about the Pythagorean converse and inequalities. So, this is a branch off of our last lesson with the Pythagorean theorem. So, let's do just a quick review. Okay. So, Pythagorean theorem says that in a right triangle, the square of the lengths of the hypotenuse is equal to the sum of the squares of the legs. Now, if you don't remember the different parts, let's just get a quick reminder. The hypotenuse is the side that does not touch your right angle. Now, this is equal to if you take this leg and square them, add them together, that gives you the hypotenuse squared. If you ever needed to identify which parts are the legs and which part is the hypotenuse, the legs are always the parts that touch the right angle. The hypotenuse does not touch the right angle. And also, as an added reminder, if C is what these two squared are going to be equaling to, that means C is going to be the largest out of these three sides. Okay? So, C, your hypotenuse, does not touch the right angle, and it is the largest of the three sides. All right. Ooh, sorry. Pulled up the next thing. All right. Now, let's talk about the name of the new thing that we're talking about, the converse of the Pythagorean theorem. So, the longest side of a triangle is equal to the sum of the squares of the other two sides, then that makes it a right triangle. So if we take a look at this triangle here, we got three sides, and they don't indicate to us that this is already a right triangle. For us to test this out, we would have to go through and run it through the Pythagorean theorem to see what it could possibly be. If it works for this, that means that this will in fact work as a right triangle. All right, let's check it out. So c squared, let's see if it's going to be equal to or less than or greater than. Let's check it out. So c squared, c is going to be our biggest side, which is 82. And that should be, if it works for this, equal to the other two sides when we square them and add them. So I go through, I hit the math up. 18 squared is 324. 80 squared is 6,400. 82 squared is 6,724. Now, if we go through and simplify the right side, we end up getting 624 is not 624. 6724 is equal to 6724, which means that, yes, this is a right triangle. So, if it works for the Pythagorean theorem as we've dealt with it, then that means that it is a right triangle. But what if it doesn't work for the Pythagorean theorem? Let's take a look. So, next we're going to be talking about this quick thing, the Pythagorean inequality for acute triangles and also for obtuse triangles. So, for this, if the square of the length of the longest side of a triangle is less than the sum of the squares of the other two sides, then that makes this an acute triangle. So this is the other version of this version of the Pythagorean theorem. Instead of us having an equal sign there, now we have a less than sign. So if we run the sides through this, and these two, a squared plus b squared, are greater than c squared, that means that this would make an acute triangle. Now you have to go through and test that, make sure as you go through and deal with it. Okay. Now, for the next one, we're talking about if it's an obtuse triangle. Now, a lot of the blanks are the same except for this one right here. So if the square of the length of the longest side is greater than the sum of the squares of the other two sides, then that makes this an obtuse triangle. Okay. So the last one had us looking at a plus b over here being larger than c squared. This one has c squared being larger than a squared plus b squared. So you have to make sure that it runs either these two or the Pythagorean theorem with the equal sign. So what we're going to do, we're going to check out this triangle down here as an example. So we got c squared is blank to a squared plus b squared. Now c squared is going to be our largest side, so that's 15. Then we got 11 and 12 on the other side. So let's check the math. All right, 15 squared is 225. 11 squared is 121, and we got over here 144 from 12. Now, if you add these, so far you can kind of tell just a couple of things. I know I'm going to get a 5, but the next one number here, 2 and the 4, that's going to make a 6. This and this, that's going to make a 2. So this actually ends up being larger than c squared. So in the case for this, since a squared plus b squared ends up being greater than this stuff over here for c squared, this is going to fulfill the top inequality, making this an acute triangle. Now, if it was the other way around, this would be an obtuse triangle. So that's essentially what we're doing here. We're checking these out. Okay. All right, let's go through. Let's get some practice in there. I think you guys got quite a bit of practice questions. Let me double check. Yep. We got the 6 up there, 6 down there, and we got these down here. Perfect. All right, so we're going to be doing the we do it together. That is going to be the next couple of questions, and then you guys are going to do the I do it and the practice on your own. All right, sorry folks. There you go. All right, let's talk about it. A, B, and C. So, given the 3 sides of a triangle, classify it as right, acute, or obtuse. So, we're going to go through and let's attach what our values are. C is our largest side, so over here, 9 is C. A and B are the other 2 sides. Doesn't necessarily matter which one is which, but we know that these 2 are A and B, and this one over here is C. So we go through. If we run the math for this, this will end up being an obtuse triangle. Now, can you tell? Let's check. We got 9 squared, just like how we had before, blank, to 4 squared, plus 7 squared. So 4 squared, I know, is 16. 7 squared is 49. And 9 squared is 81. Now, off the rip, I can already tell you that this isn't going to get all the way up to 81. Because if you add the 1 from the 16 over to the 49, that gets you to 59. The 6 plus that 59 would end up bringing you up to, that would be 65. So that makes this side here, c squared, larger, making this an obtuse triangle. All right, let's check the next one. We got our C here. We got A and B. Let's check it out. We got 16 squared plus, not plus, my fault. Let me go and erase that. 16 squared, and we got our blank, and then we got 10 squared. Ooh, this computer just don't want to operate with me right now. It's over here walling out. Okay, there we go. All right, 16 squared, 10 squared, plus 13 squared. All right, so I know 10 squared is 100. Okay, hitting me like this again. Boom. There you go. So we got 100. 13 squared is 169. So this is going to be 269. Now, this pen is just doing a lot, people. All right, 269. Now on the other side, I don't know off the top of my head what 16 squared, but I do know that it is larger than 225. So let's pull up our calculator just to make sure. All right. Now I know the answer just popped up, but it's always good to do our due diligence. We got 16 squared which is 256. 256 is obviously less than 269. So because of that, that makes this an acute triangle. All right, next one we got 11, 8, and 8. 11's our C. We got 8 and 8 being A and B. So let's rip up the calculator. Let's pull it up. All right. We got 11 squared is 121. And we're looking for 8 squared plus 8 squared. That's 64 plus 64. That's 128. So because of that, that means that we got us an acute triangle because 121 is less than that. Oop, don't want to give you anything else. Ooh. Hey, yo, there we go. All right, folks, I'm going to leave the other ones for you, and I'm going to catch you guys later. See ya.